Well, so welcome to this talk. Thank you very much for turning up. I'll be talking about um, change and what organizations can do to manage the change and actually master it and help themselves to be more agile and deliver faster. Um, of course, using StreamSets. My name is Giuseppe Mura. I'm head of solution engineering at StreamSets. And when I talk about change, I would like to kind of, as you can see, I've got a few white hair and a white beard, so I've been around for a while. I've seen quite a bit of change in the last 20 years of my career. Some of the changes that I'd like to talk about include changes in infrastructure, changes in applications, and the data that they hold and manage, and also maybe some of the people, processes, approaches that we've seen. Big changes there. So when we think about all those changes, what can we do to insulate the investments that we're making from that change, but also actually enable us to adapt, respond, and evolve our data ecosystem to drive that change and benefit from it. So, and finally, of course, I want to talk a little bit about how you can do that using StreamSets technologies. So, what you can see there on the left-hand side is the typical thing that I had to deal with when I started my career. And I still claim that my lower back problems are down to me spending time in a data center attached to a keyboard and a video, and in the cold, freezing, air blowing over me. And fortunately, not much of that is around anymore. There is still some. So most likely, some of you will be working for a large corporate organization with still a substantial investment in on-premises data centers, applications deployed on those, and obviously data residing within the confines of your data center and firewall. But over the last few years, certainly we've seen a massive evolution in the last 4 or 5, even financial services institutions that until 3 years ago were swearing they would never go to the cloud have actually gone to the cloud and are busy moving substantial amounts of their data, applications and services to maybe AWS or Azure or Google. And of course, that big change means we need to think about different kind of problems. So security of data as it's transported between applications is probably something that we need to be much more conscious about than we were maybe 5 years ago when the data transfer was happening within a data center, our own data center. So that's one aspect. The other aspect is data structures themselves, and the applications that consume the data generate different types of data structures. So when I started my career, the first few projects were around ERP implementations, SAP perhaps, or Oracle Financials, or maybe CRM systems, which started gathering fundamentally transactional data in a very structured format, tabular format. Actually, over the last 10 years, things have evolved. We've gone through XML as a protocol for transferring data, which was extensible and much more flexible, to finally land into a world where most of the data transfer these days is happening over JSON formats. Hierarchical in nature, very unstructured, changing all the time depending on applications that are revving up very quickly and disrupting the formats of data that we are consuming as part of our data flows. And actually the interesting thing is that when we look at the way that we sought to manage these different data structures over the years, on the left hand side we had databases, and we all recognize an Oracle database, a SQL Server database, etc. On the right hand side, we can think, well, actually, how have we managed these data formats over the last few years? Well, we've thought about data lakes, for example, and dumping the data into data stores and then worrying about maybe extracting the content and organizing the structure later on. Great. What's happening now is actually things are converging and converging in a number of different ways. So we have databases that are fully capable of storing semi-structured or unstructured data. So we need to respond to that and manage that as we go forward. Of course, that it's got implications in terms of the integration patterns that we develop and put into production. How do we insulate them from the evolution of schemas, for example? How do we ensure that as the new columns are added to a database or new elements are added to a JSON payload, that doesn't break our integration patterns and doesn't stop our applications from consuming data. Next, I would like to think a little bit about actually looking back at when I started, and probably coming out of university, getting into IT. My first steps, we very much were thinking about big application delivery through a sort of a waterfall model, maybe centralized by IT with a very formal description of requirements and many steps to get into our application into production. Over the years, there's been a sort of an effect, probably somehow we can refer to that as a democratization of information technology, self-service, consumption of data, business intelligence, etc., which has pushed the delivery of and the consumption of data from a centralized IT services towards lines of business. And certainly the methodology around the delivery have gone from, very much a sort of a waterfall towards agile and so on. And in that sort of new modus operandi of delivery of data, certainly other patterns have emerged, including things such as data mesh and the focus on data products and so on, which actually again put the onus of the delivery much more towards the business process owners and the experts in the business on the data and the applications, and for them to be masters of what they deliver. Now, clearly, all this requires a different approach. So the kind of skills and the kind of roles of people that we commonly interface with is no longer just architects and developers, but is business analysts, data analysts, who perhaps are not as familiar with maybe programming languages and infrastructure and that level of complexity, and require some tooling that will allow them to prototype deliveries much faster, maybe in a graphical fashion. So, in summary, changes stretching from infrastructure, from applications and data. Delivery methods are different. What do we as StreamSets believe are the key core capabilities that are needed to enable organization to cope with that change and actually drive innovation? First of all, and this is something that is very core to what we believe in, is abstraction. So building integration patterns, and I stress the word patterns because in organizations typically there are a handful to a dozen different patterns of integration, and creating those in an abstracted fashion so that they can be applied to different applications, to different data sets, different, if you're building data products, and encapsulating the logic that we want to apply into some kind of abstracted interface that is not enmeshed and entangled with the specifics of the infrastructure that we're using, whether it's an Oracle database versus a file system versus a message queue, and or with the structure of the data themselves, because those structures will keep changing. So that's very, very important. Part of this, of course, comes from our heritage in, delivering big data systems, and dealing with constantly changing formats that need to be onboarded into big data stores. But it extends beyond that. Other elements, and we'll touch upon those, are the fact that the templates that we build actually need to span a wide variety of use cases. So if we think of implementing a data strategy that incorporates a data management technology such as StreamSets, that platform needs to be able to cope with all sorts of different patterns and do that in a consistent fashion, so without fragmenting into 100 different tools and experiences. And then also we need to think about automation. Very important, because if we plan to do that at scale, we can't expect users to handcraft implementations for every time that they need to move data between points A and point B. And ultimately, we need to think about all the enterprise abilities that we would need: scalability, security, etc., etc. So, having a look at those various elements. So, if we think about abstraction, what does abstraction give us? Well, first of all, it gives us flexibility. It means that we can build one template, one pipeline, we call it, in our platform, and that pipeline can cope with different data structures, different files, different databases. So probably we can end up with creating one template instead of 100 different implementations specific to the various endpoints that we have. Secondly, because we are abstracting the definition of logic from maybe the data structures or the data sources and targets that we're connecting to, we can also think about minimizing the specifications, so making the development environment very, very rapid, and also resilient from change. So what do we mean by that? Again, if a table is modified by a source system and we're building a data integration pattern that moves the data to a data lake or a data warehouse, should that integration pattern break just because a table has been modified? Well, clearly not. We should be able to cope with that change seamlessly. The new columns should flow into our data lake or data warehouse, and maybe somebody should be alerted of the fact that the change has happened upstream beyond our control, but not break the integration. And ultimately, all that will help in making us much more efficient, because we reduce the number of breakpoints in our architecture and ensure that we reduce the cost of maintenance. So that schemaless engine and drift awareness, or being aware of any changes that come through, is really foundational to our design, and actually is baked into the platform. Now, the platform, though, needs to cope with a variety of use cases. So organizations that come to StreamSets typically come to us for one or two initial use cases that may be an ingestion of data from, Salesforce to a data lake, or from Oracle to Snowflake, for example, from an operational system to a data warehouse. But very quickly they discover that the platform itself is suitable for a whole variety of use cases. Here I represent a few. There are many, many more. Please come and talk to us afterwards if you're interested. I like to organize them in probably 2 or 3 different buckets. So one is generally analytical data flows, taking data from operational systems, pushing the data into the modern data platforms, be that a combination of data lakes, data warehouses, lake houses, whatever we want to call them. So certainly we can facilitate that. And it's not just flowing the data into these systems, it's transforming the data, standardizing, conforming, and so on. So all the elements of data ingestion, streaming ingestion, ETL, ELT patterns, as well as distribution of the data from maybe a lakehouse or data warehouse into operational systems that might want to consume that. The other pattern is all around streaming applications. So here, accompanying streaming platforms such as Kafka or Event Hubs or Google Pubs Hub or some other kind of streaming persistence storage, and providing the ability to link that or bring data to those platforms from systems that by nature were not designed to be streaming platforms, maybe legacy databases, maybe simplifying the integration of APIs, API-based processing around these platforms. And then ultimately data lakes processing, whether that is on premises, and there are still a few of those, or the data lakes have been lifted into the cloud, be that on AWS, being S3, or Azure Data Lakes, or Google, and of course Databricks as well. Now, to do all that, all good, of course we need to do that, but we need to provide a single interface, a single user experience that we can put in front of the developers, whether they're classified as developers or data engineers or whatever we want to call them. And actually the profiles will be slightly different depending on the roles, but we provide a single console that user can use to implement all those use cases. So we don't need to fragment the solution across a number of different components. And what we provide the user interface for is obviously to allow the design, the deployment, the operational monitoring and management, and of course the security of the solution. So just looking a little bit what we provide, that platform provides users with an interface that, regardless of their use case, allows them to define these data flows. We call them pipelines. It's obviously got a bunch of built-in connectors that allow users to connect to applications, databases, file systems, all sorts of different data stores, and provide out-of-the-box transformation components that can be dragged and dropped onto the onto the canvas. Now, the important thing is that actually those components can be grouped together and turned into reusable fragments, we call them. And fragments are effectively, think of them as data processing functions that can be applied within data flows. So abstracting functionality from the endpoints that we connect to. And those fragments could implement any type of logic that will manipulate the data, transform the data, enrich the data through calling APIs or machine learning or whatever else. So I'll walk you through some examples, and just to showcase the variety of use cases that can be implemented. This is a typical pattern of data ingestion. So maybe an initial load of a database into the cloud. Interesting thing here is that we don't need to specify within the pipeline itself the structure of individual tables that we're collecting from the database. We can actually tell the pipeline to go and collect all the tables in one or more schemas, in this case a MySQL database, and replicate that data across into Snowflake, for example, as well as a Google Cloud Storage data lake. In this case, the customer would have, for example, the source system on premises behind the firewall. So our ingestion component would be deployed onto some infrastructure that resides close to the source database on premise. Once the initial load has been performed, we can switch to feeding changes in a continuous stream using change data capture. So consuming the transaction from the database log, and just pushing the transactions through. So again, we have built-in connectors that deliver change streams on one side and optimized components for loading data into a cloud data warehouse as Snowflake in this example. Another pattern could that be of actually, and we've seen quite a few of these, customers who have legacy implementations of data lakes on premise and are pushing them to the cloud. And you can see that the pattern is very similar. So there is the same UI. The technologies under the covers are very different. In this case, we are running our engine on Hadoop data lake, and we're using Spark to collect the data and push the data through to the destination. So in this case, we are actually streaming data. As new files are added to our on-premise data lake, we just keep pushing them to the cloud storage. In this case, it's Azure data lake. And these examples kind of roll on. So in this case, we have BigQuery, and we're shifting data from BigQuery to Snowflake. We have seen a lot of customers who have started their journey moving data from on-premise to one cloud, and then actually added another cloud, and then started moving data from one cloud to another. It's a very common pattern, whether that is happening from data lake to data lake or data warehouse to data warehouse. It doesn't really matter. We can accomplish all those. Clearly, we need to consider the fact that we need a flexibility to deploy the processing engines in the most appropriate place. In some cases, it could be on-premise. In some cases, it could be one cloud or another. We can probably also have to think about scalability. Things like, are we running one engine, or are we running a number of different engines? Are we scaling out the workload across those engines? And so all elements that we can think about and take care of. Other examples involved very commonly ingestion of IoT data. So we have support for IoT streams built into the platform, consumption of data from network, from the network itself, or from OPC servers, from obviously from streaming platforms that may be providing us the IoT data streams. In this case, we're going to Kinesis, we're going to Elastic. So as you can imagine, there are a lot of different patterns for the consumption and processing of IoT data. Next, the next example is actually slightly different. This is a pipeline that processes data at scale on Spark. So clearly, when we're looking at processing high volume of data, and we want to perform very complex transformations, joins, aggregations, whether it's in streaming mode or batch mode, it makes a lot of sense for us to use Spark. It's very scalable, it performs very well. It is somewhat hard for the average data user to consume, so we've abstracted away from Scala, from PySpark, and provided the same user interface that our users are familiar with, just added the constructs for some of the specific operations that you might want to perform on top of Spark, and under the covers, we take the pipeline definition, translate that into a Spark application, and execute that on the cluster. And of course, for customers who have an investment in a cloud warehouse such as Snowflake, we actually have applied ELT processing paradigm to the execution of these pipelines. So these pipelines are interpreted at runtime and translated into SQL that is executed on Snowflake. We under the covers actually we use Snowpark, which means that the pipelines can be very flexible, can dynamically adapt to changes in the data structures. They're not tied to the structure of the tables that we're consuming, and at runtime they're executed on the Snowflake data warehouse itself. So there are obviously more patterns: reverse ETL, pushing data out of the data warehouse and to maybe operational applications. In this case, maybe Salesforce. There are patterns around microservices where we have logic that we have implemented, maybe again implemented as a reusable component, so it could be a fragment, and those can be exposed as microservices that can be called from our applications. A whole range of these, including machine learning capabilities built in on top of maybe Scala on Spark, or maybe scoring models called in-flight as part of a streaming application for maybe fraud detection, next best offers, whatever else other predictive model that we may have created. So single user experience, lots of different patterns. I hope I've touched upon a couple of them that may be relevant to you. Come and talk to us about them. One more couple of things I wanted to mention. Having a user interface that is graphical, easy to use by developers, is maybe business analysts, for them to understand what's actually happening through that pipeline. It's all very well and good, but what happens when you hit the use case that requires something special or something specific or something that you've already used in the past and you would like to reuse? Well, the platform should be able to accommodate for that. In our case, it's very extensible. We can include scripting processors as part of the flow, which actually means that if you have Java libraries, Python modules, or Scala libraries that you've developed and want to reuse, you can bring them in and basically build the support for those within one unified platform. Also, it means that if you hit some kind of specific data processing requirements that you can't accommodate through the graphical interface, you can extend the use of the platform to that by using one of these scripting processes. The other element, which is super important, is everything I've shown you, all those use cases, all those implementations are all graphical, but they can actually be developed programmatically using an SDK. So this is really important because it means that if you don't have one database to replicate, you have hundreds of databases to replicate. If you have integration patterns involving maybe data processing within the data warehouse that can be applied to different types of maybe dimension table loading or whatever else, all that can be done programmatically and just parameterized with your own specific parameters. So to support that, we offer both APIs, REST APIs, as well as a very sophisticated and complete SDK, which can be used to both develop the pipelines, deploy the components, deploy the pipelines. We call them jobs, monitor the execution, the scheduling, etc., etc. Every aspect of the platform can be managed through the SDK, providing opportunities for automation and higher quality deliverables. And finally, of course, we need to support change in growth of number of users, number of use cases, and of course of data. So in order to support that growth, we provide a very much a hybrid architecture, allowing the deployment of components wherever you require, and we provide horizontal and vertical scalability, of course. and take care of all the other kind of abilities that you would expect out of enterprise data integration software. So high availability of platforms, failover capabilities, security, roles management, etc., etc. Thank you very much for attending this talk. If you want to talk to us, we have a booth around the corner. Just come and see us there. I'll be happy to talk about your specifics. And you can also obviously try our DataOps platform by going to our website and clicking on the try me or demo button, and you can certainly experience the platform. Thank you very much for your time.